So I want to talk about the abstract supersymmetry modeling. Before sort of the discussing of the this overlap string model with the supersymmetry breakings without them, we choose to make the breaking mechanism of supersymmetry because there are no evidence of the supersymmetry particles in the experimental observation, so there was no mass generalized between the original standard model particles and the supposed particle as a super partner. So there are some several mechanisms of the supersymmetry breaking mechanisms and the in the analogous with the Higgs mechanism, so we can make this spontaneous supersymmetry breaking. And because the from the supersymmetry algebra, such a supercharge Q and Q are dagger, anti-commutator of such supercharge is proportional to the power matrix and the momentum p mil. So if we calculate the some supercharge scales expectations of the supercharge, the answer it will become proportional to the energy. So and the supercharge acts on the vacuums because there are some supersymmetric transformations can be expressed as exponential, IQ, and Grossman variables, and as infinitesimal transformation of the exponential forms, such as supersymmetric transformations can be expressed with the supercharged Q. So if supercharged operators are acting on the vacuum size, tangent with zeros, it means that the supersymmetry is the good symmetry of the theory. So vacuum starts with the invariance and such a supersymmetry transformation. But if the supersymmetry is broken, then such a vacuum site is not invariant under the supersymmetry transformation. So acting on the vacuum size for the supercharge becomes the zero, and it means that energy is not equal to the zero, so that the vacuum starts. So it means that the minimum of the potential is not equal to the zeros in the supersymmetry broken situation. So if the minimum of the potential, especially the minimum of the scalar potential, because only the scalar fields that can have the vacuum expectation value to satisfy the Lagrange invariance condition. So if the minimum of the potential is not equal to zero, then the supersymmetry will be spontaneously broken. That are some of the wisdoms of the supersymmetry breakings, and there are several mechanisms of the spontaneous supersymmetry breaking, and we can give some several potentials of the scholarship of P, so-called scholarship of P. We know that such as superpotentials can be expressed as a polynomial of the scholarship of P, and we only consider that the just the pi scales and the pi does. We already discussed the dimension analysis for that is potential, and there are some several coefficients in here, and if there are some three color Schiffer fields, and we can give them some such Schiffer potential, some specific form. There is a pi 1, pi 2, pi 3, three color Schiffer field, and three parameter and lambda and the mu scales, and such as superpotentials will have the always the non-zero minimums, and supersymmetry will be the spontaneously broken. So, for example, the superpotentials given like that, the most general forms, and the from that we can calculate the some derivatives of the superpotential, and such each color field contain the component P, scalar field, spinor field, and one auxiliary field which could up, and we want to remove the such up term, and because the such auxiliary field up does not have the kinetic term Lagrangian, so we can remove the up term by the equation of motion, because partial R's, partial R's equal to 0, the quadratic term. So automatically partial R is equal to 0. And in the Lagrangians, there's R's here, several terms, and there will be some linear terms with the R's, and some components term will be located in here. And it will make a derivatives of the R's, and it is that the some octal fields R can be expressed in terms of the other component field, and we can remove sort of the such octal field, and especially the such R's terms can be obtained by the derivative of the shape of V, and all Grossman variables is equal to 0, and proof is just the attached in here. Now just some specific examples I already explained. There are a lot of scales terms, and if we derivatives of the F's, then the derivative is like that. And for this super potential, there will be the F1s, F2, F3, which coming from the pi 1, pi 2, pi 3 respectively. And also we can remove sort of the such F terms. Just the derivatives of the super potentials, and instead that the Gaussian variables are equal to 0. So just the select this color path. Then the is the such F octal fields can be expressed with this color field pi 1, pi 2, pi 3, not capital pi 1, pi 2, 0. This is the small pi 1, pi 2, pi 3, which is the component field, not the super field. And because the remaining term is just the upscale term, so the color path terms can be expressed as pi 1, pi 2, pi 3, and also its Hamilton conjugate. And this is some color potential part of the super potential. So super potential W is capital pi I. It contains the several components, and we can only select the color paths by the calculating of the accelerometer base of the up. And now we want to consider that the such as color path, color potentials, small pi 1, small pi 2, small pi 3, and there are some coefficients, some coupling constants lambda and the mass m and the mu scale, and such as color potentials has always non-zero minimum, and it means that supersymmetry is a spontaneous vacuum. We can find sort of the minimum sort of the such as color potential spot that is similar to the Higgs mechanism, just sort of partial V's, partial pi 1s, and the partial pi 2, small pi 3. And for some several parameter the setups, for example, mu scale is bigger than the m scales of the 2 lambda case. The potentials are given like that. There are very some similar behavior in Higgs mechanisms, and minimums are here and here. And because the minimums of the potential is not zero, the supersymmetry is a spontaneous vacuum. And also the mechanism of Gaussian values of the color beads is also non-zero, and it gives us some correction for the color mass. And in the upper side can instead of mu scales standard m scales of the 2 lambda, then the minimum positions that located in the small pi 3 is equal to 0. Even though the vacuum expectation value is 0, the minimum of the potential is non-zero, is bigger than the yes, that's a positive value. So remember that supersymmetry is always spontaneous vacuums with such forms of such potential. And I already explained this part. Spontaneous supersymmetry vacuum, such as QQ bars, anti-commutative of the supercharge are proportional to the momentum. And if we calculate the vacuum with fluctuation values simultaneously, it will be proportional to the scales of the supercharge. And the supersymmetry transpose that means that the supercharged acting in the vacuum is that the zeros that means that the vacuum is invariant under the supersymmetry transformation. And if the potential has a non-minimum, so then the supersymmetry was spontaneous breaking. Also, we can calculate the mass spectrum from the such often breaking because there's some skills second derivatives of the super potentials to the parameter mass matrix as a quadratic. Also, some super potential part. There's some levels of mass matrix, and because the potentials are related with the upstream, so such as minimum locations of the potentials that are epoxy fermions and the bosons mass. And there are some several other supersymmetry spontaneous breaking mechanisms like the lithium breaking or the Gazi medial symmetry breaking and the Planck scale supersymmetry breaking thing. And maybe they deal with this case next time.